next problem is called middle of the linked list. We are given the head of single linked list, and we have to return the middle node of the linked list. If there are two middle nodes, basically if the number of nodes is even, then we will have two middle nodes. We have to return the second middle node. So in the first example, we have a node list. So the middle element, of course, is basically the element 3. And if we return the head, the remaining nodes will be 3, 4, and 5. But basically, because we are removing this node, it will become a head of this sublist 3 and 4 and 5. If the number of nodes in the list is even, then we have to return the second middle node. So basically, these are our two middle nodes, and the second one is the node 4. So basically, we will be returning this as the head of the sublist 4, 5, and 6. The number of nodes is in the range 1 to 100, and the node values are from 1 to 100. This problem is easily solved using a slow and fast pointer approach. Basically, if we put the slow pointer to move one node at a time, and the fast pointer to move 2 nodes at a time, when the fast node reaches the last element, the slow pointer would have crossed the half of that distance, which basically means half nodes, and it would point to the middle element in that case, because it covered like the half element. So the last element it covered was the middle element. But let's see if that works for both the even and the odd number of nodes in the list. So in this case, for the first example, we have the total number of nodes here is 5, and then for the second is 6. So we have the odd and the even number of nodes list. We will put our pointers for both of them to point to the first element, basically the first node, the head of the list, and we will move the fast pointer 2 nodes at a time, and the slow pointer one node at a time. So first thing that we will do, we will move our slow pointer to point to the next element, and we'll move our fast pointer to first go to here, to the second element, and then go to the third element, because we are moving to 2 places at a time. Next, we will move our slow pointer to the next element, and we will move the fast pointer to first this element, and then because we are moving two nodes at the time, we'll move it to here. So slow is pointing now to the node with the value 3, and the fast is pointing to the node with the value 5. The next time when we are stopping our traversal here, because fast we cannot go to places for the fast no more. Basically, this is a null element. So you already reached the end of the list, and we are returning the node to where the slow pointer is pointing to in that moment. So in this case, it will be this node. As we can see, the middle node. Now, if we go to the second example, we will have both pointers pointing to the first element. Fast will then go to the second element, and then to the third element, because we are moving 2 places at a time. And slow will be pointing to the second element. Next, the fast will be pointing to this element, and then to this element. And slow will be pointing to the third element. Finally, we will go to the fast. Fast will be pointing to this, and then it will point to the next element, which is basically a null. And when we move our slow, it will be pointing to the second middle element, which in this case is the element 4. So basically, this algorithm works for both the odd number of nodes and even number of nodes. We'll make our slow and fast pointer both point to the head of the list, and then we will move as long as fast is not equal to null, and also the next element of fast is not equal 1, because we are moving 2 nodes at the time, and for each iteration, basically. Next, we'll move slow pointer by 1 place, and the fast pointer will move by the next. We do that by doing the fast next. So first we are moving to the next element from the current position of the fast, and then to the next element from that position. And then finally, we'll just remove the slow pointer, because it will be pointing to the middle element. It has covered the half of the total number of nodes, because fast is now pointing to the last element or the null element if the number of nodes is even. And because we are not creating any additional data structure, we will have context space complexity, and we are traversing the list only once, so we'll have linear time complexity proportional to the number of nodes in the linked list.